Good morning. Today we will discuss numerical problems on three-phase AC circuits. In the last lecture, we have seen the relation between the relation between line and phase quantities in three-phase star connection and also in delta connection. We have seen that in three-phase star connection, the magnitude of line voltage is √3 times that of phase voltage, whereas line voltage leads phase voltage by 30 degrees. Whereas IL is equal to I phase, magnitude point of view, and both have same phase angle. Whereas in a delta connection, voltages do have the same magnitudes, line and phase, and angles are also same. Phase angles are also same for line voltage and also phase voltage, but magnitude of IL is √3 times that of I phase, and line currents lag phase currents by 30 degrees. And the power consumed in three-phase AC circuits, active power is √3 VL IL cos phi. Reactive power is √3 VL IL sin phi, and total power is √3 VL IL. So these are the things which we have seen in the last lecture. Now we will try to solve problems on these formulae. I hope that by the end of this lecture, we will be able to calculate line and phase quantities in three-phase star and delta connected networks. So this is a problem which has been given for you. There is a balanced star connected load of 8 plus J6 ohms, and it is connected to a three-phase 230 volt supply, which means that there is an impedance 8 plus J6 ohms, and it is connected to a star connection, and each impedance is of 8 plus J6 ohms, and there is a supply of three-phase 230 volt supply. See, always the mentioned value will be line to line value, and it will be of RMS. So when these things are given for you, you should determine the line currents, phase currents, power factor, active power, reactive power, and total power. So now, let me start with the basic diagram which I have already given for you. So let us note down what has been given for us. The first thing. So as already mentioned, normally the voltage given will be RMS line to line voltage. So given it is 230 volts RMS line to line. So impedance is given as 8 plus J6, and then they are saying that the load is connected in star. So the equations which we do have already, these are regarding the magnitudes. And angles VL will be leading V phase by 30 degrees. Whereas here, both have same angle. So of all these four, you take one thing as a reference. So I am taking V phase as a reference. Okay. So what I am doing is, first of all, I'll consider phase voltage as reference. Okay. So first let me calculate what is V phase. Since it is star connection, V phase magnitude is VL magnitude by √3. VL is given as 230. So 230 by √3, I'll be getting 132.794 volts, and this is RMS value. Okay. Now if I want maximum value, what I should do, we have discussed in the last class. It is √2 times of V phase RMS. So it is 1.414 into 132.794. Okay, you'll get somewhere around 187.7. Now, we'll start with these are the phase voltage. So, if I want for all VRN, VYN, and it is VPN. So, how they will be? One is 132.794 at an angle of 0. You take this one as a reference. So, the remaining will be at minus 120 and minus 2. So, these are being taken as a reference. Phase voltage are taken as reference. 0, minus 120, minus 2. Then we will calculate line currents, phase currents based upon this reference. Now, this is sinusoidal. So, this is polar representation. Now, if I want to convert it into a phasor representation or a sinusoidal equation, so how I should write the instantaneous equation? So, this is RMS value. Generally, what I should write? I should write it in this fashion. This is instantaneous equation. This is maximum value, but whereas this is RMS value. So, what I should write here? Maximum value I have already got it as 187.7 sine omega t. What is angle? 0, right? Here it is 187.7 sine omega t minus 1. This is 187.7 sine omega t minus 2. So, these are the phase voltage only. Okay. Now, we will move on to line currents now. So, phase currents and line currents. So, we do have phase voltages. So, VPH we do already have, it is 132.79, and we will take for the reference as R. So, it is 0 degrees, right? This is VRN, right? This is VRN. Now, if I want phase currents, if I want IR, what I should do? VRN by Z R. What is VRN? It is 132.79 by 0. What is the phase impedance? It is 8 plus J6. Now you convert this one into rectangular form. You will get, polar form. You will get, see the magnitude should be divided. You will get 13.279. Angles must be subtracted. So you will get minus 36.86. See, this is amperes and it is RMS value only. If you want maximum value, so this is RMS. If you want maximum value, it is root 2 into 13.27. Okay, you will get somewhere around 180.18.18 like that. Okay, so now if you want to write it in instantaneous equations, right? What we have got? IR, I have got 13.279 at an angle of minus 36.6. So IY will be 120 degrees lagging from this one. It is minus 156.6. IB, it will be still lagging 120. So it is minus 120. So I'll get minus 276.6. So if I want to write as instantaneous, this is RMS. So what is the maximum value? 18.77. This into root 2 sine omega t. This is angle, right? Similarly for this one, minus 156.6. Again for this one. This is the way how we write. These are the phase currents. Now line currents, this is a star connection, right? As already I told you, line currents and phase currents both are same. So that's why even for the line currents also, I'll repeat the same. See here. These are the phase currents, line currents also they remain the same because it is a star connected load. Now, the next thing is power factor. Power factor is cos of phi, where phi is angle between phase voltage and phase currents. Phase voltage, I'll take R phase, VRN and IR. VRN was at an angle of 0. This was at an angle of minus 36.86. So what is the difference between only the angles? 36 degrees. So I'll take it as cos 36.86. It is 0.8. See, which is lagging? Current is lagging, right? So I'll take it as 0.8 lagging. This is perfect. Now if I want powers now. So how to obtain the powers? P is equal to root 3 VLIL cos phi. Or I can take 3 VPH IPH cos phi. I should consider only magnitudes, right? So 3 into the magnitude is 132.794 into this is 13.279 into 0.8. Whatever the value which I will be getting, that is watts. Similarly for Q, what I should do? 3 V phase I phase sin phi. What I will be getting? Watt. Similarly for S, 3 VPH IPH. The units is VU. Right. So this is the way how we solve the problems. Now, if the same thing is being given to delta connected load, now how the differences will be there? See here, the same impedance, the same magnitude now, but the connection is in delta. So now let's see what is the difference in this one. See, the given things, they remain the same, but the only difference is that it is in delta connection. In delta connection, what is the condition? VL is equal to V phase in magnitude and angle, but whereas currents are these things. So the magnitude of phase voltage, how it can be computed? Very simple. It is just same as the line voltage. It is 230 volts RMS. If you want maximum value, V phase maximum, it is 230 into root 2. It is somewhere around 325 to my knowledge. Okay. See, that's why when I try to write phase voltages, what is VRM? It is 230 at an angle of 0. The same is VRY also. Both are same. Okay. Which means 325 sin omega t plus 0. Similarly, VYB. Sorry, here there is no neutral. This is, there is no neutral. Okay. This is YVB. So here again what you will getting? 230 at an angle of minus 120. Which means 325 sin omega t minus 120. Again it is VBR. It is again 230 at an angle of minus 240. What I am getting again? 325 sin omega t minus 240. These are the line voltage and also the phase voltage also. Okay, because in delta, VL is equal to V phase, both in magnitudes and also angles. Now, currents. Now, how to calculate the currents? You know, phase current is equal to phase voltage by impedance per phase. Which phase I am considering? I will take R base. So this is IR, I will take. This is VRY, I will take, and this is 8 plus J6. This is IRY. Okay. So this is 230 at an angle of 0 by 8 plus J6. We have done it already. And I will be getting 23 at an angle of minus 36.86. See, earlier I have got only 12, somewhere around 13. But now what I am getting? 23. For the same supply, if I connect it in delta, my current is increasing. Isn't it? So, if I want to write it in phasor form, yeah, see, this is my IRY. This is my IYB. This is my IBI. So this is the way how I will be writing my phase currents. Now if I want line currents, what I should do? I should multiply it with root 3 I phase. Because in delta, my line current is root 3 times of phase currents in magnitude. Angle, it must be lagging by 30 degrees. So what are the angles now? See here. Earlier, my RY was 325 sin omega t minus 36.86. What was my YB? It was 325 sin omega t minus 156.86. What was my BR? Now I should get line current, right? What is a line current now? IR. Magnitude should be multiplied by root 3. Okay, I'll get, sorry, this was 32.5, right? 32.5, right? 32.5. So 32.5 into root 3, it is somewhere around 56.32. An angle also should be lagging by 30 degrees. So I'll get 66.86. Similarly, IY. 56.32 sine. Once we get one value, the remaining we can just adjust it by adding 120. Right. This is the way how we see what is the relation between these two. Root 3 times. These are phase currents. This is line current. Root 3 times magnitude, and angle is, see here, angle is lagging 30 degrees. This is what I have implemented. Now coming to the power factor. Power factor, it remains the same whether it is star or delta. There will be no change. See that difference between the angles remains the same. So I will be getting cos. This is for phase voltage. This is for phase current. You can see in the previous slides, cos 0 minus of minus 36.86, you will get 0.8. Since current is lagging, I will take lagging. Similarly, power consumed. Now here comes a difference now, if you carefully see. It was 230 magnitude and it was 23. And power factor is 0.8. You can see 12,696 watts. See a huge difference when compared to the previous case. The power has increased a lot. Similarly, the Q 9522, the S 15870. Right. When I go with a delta connection for the given same supply with the same impedance, then automatically what happens is my current is going to increase. Okay. So I hope that now you are able to calculate the line and phase voltage and currents of the 3-phase star connected and delta connected networks. Okay. So try to solve these problems. Come back to the class and we'll discuss some more problems. Okay. Thank you.